Ladies and gentlemen, hello and welcome. Thank you for attending today's webinar, Fast Track Intro to Azure Synapse Tips and Demo. Before we begin, I'd like to cover just a few items regarding this webinar platform. At the bottom of your screen, you'll notice a handful of widgets, mainly the Q&A widget, which you can utilize to submit any questions you have throughout today's webinar session. For viewing purposes, you can also expand your viewing window by clicking on the icon found on the top right corner of the media player. If you have any technical difficulties, please click on the Help widget. And lastly, do take a moment to fill out the survey at the end of the webinar. Thank you. At this time, I'll turn it over to your presenters, Megan McCann, Partner Development Manager for Data Services at Microsoft, Liz Barrett, Data and AI Practice Manager for Insight's Raleigh team, and Ted Tasker, Data and AI Practice Manager for Insight's Columbus team.
Thank you. Yeah, thank you everyone for joining today. I wanted to start off by introducing Insight. I have the pleasure of being able to work with Insight from a data services perspective at Microsoft. So I work across all of our global partners to help them develop and grow data services practice, and Insight is one of the top partners I support. So it's great to be here today to introduce them on this fast track into Azure Synapse and some of the tips and demo that we'll get to see today. So as a Fortune 500 ranked global provider of hardware, software, cloud, and service solution, Insight's 7,000 teammates provide customers the guidance and expertise they need to select, implement, and manage complex technology solutions to drive business outcomes. From business and government organizations to healthcare and educational institutions, Insight empowers clients with intelligent technology solutions to realize their goals. Within data and AI and the kind of work that I get to do with Insight, I can see that they leverage a lot of Azure solutions, from our analytics to IoT to machine learning to connected data platforms, and they were Partner of the Year for Microsoft in AI in 2018. So now it's more important than ever that all organizations are thinking about their own capabilities around analytics and AI, as the move to digital is becoming a fast-paced reality for the world. Insight is actually working to solve these new challenges that we're seeing in the world with their customers. They've been creating connected solutions that promote social distancing with proximity alerts. They have deployable portable virus testing and have solutions that help detect temperatures of people's in rooms for real-time monitoring. Plus, they create advanced analytic work that help us get the true insights out of our data. They're one of our key partners when it comes to supporting our customers on their journey to digital innovation. So we look forward to providing a deep dive with you today on how you can meet your analytic needs with Insight and Microsoft. So now I'll hand it off to Liz from Insight.
Great, thank you, Megan. So I'm going to go ahead and post a couple of poll questions just to get a sense for the audience that's on the call. The first question is around how long it takes for you within your internal organizations to take something from ideation to production. So really around your deployment timeframes. The second question is to get a sense of how many of you are already using Microsoft Azure today. So I will go ahead and ask these two poll questions, so be on the lookout for that. And I will, in the meantime, kick it over to Ted, who will introduce himself and talk a little bit about what we will cover today.
All right, thank you, Liz. So yeah, my name is Ted Tasker. As you heard, I'm a practice manager for data and AI at Insight. I've been working in the data warehouse analytics space for over 25 years. Almost all of that has been on the Microsoft platform. And so when we look at what it is we're going to be talking about today, and there we go. The first point that was in the invite, or the place where you signed up, said, get an understanding of data warehousing and how it's evolved over the last 20 years. I'm certainly one who can comment on that, because I've seen where we were, and seemed exciting and fast-paced then, even though it often took a year for a project to get up and running and actually deliver anything. And it's still very exciting today to be working in the data warehousing space where we've got the cloud and you can get started and literally do what we're saying up here, a fast track into getting something up and something that can help your company, in the matter of weeks now, rather than months or years. So we'll talk about data warehousing, how it's changed. We're going to explore the Azure Synapse Studio. So this was just released back on May 19th to public preview. So it's available now for people to go in and start working with and playing with. And sort of leads into that next point of learning how Azure Synapse unifies the tools for all roles involved. And one of my goals today is going to be this, to make sure everyone's got a fairly clear understanding of what Azure Synapse is, because you'll hear the reference to Azure Synapse, which is pretty all-encompassing of a lot of services that are available. You'll hear Azure Synapse Studio, which is one of the tool and the key tool that lets you work with everything. Mind you, many of the underlying pieces, you can still use other development tools that you might be familiar with. And then when we talk about optimizing analytics, I'm going to dive in there, excuse me, a little more to Azure Synapse pools. And that would represent the relational database aspect of the data warehousing. So as we go through, hopefully we'll get a good idea about really what Azure Synapse is. There we go. So we're going to talk again first about data warehousing. And so, Liz, hopefully you got some answers to the survey. So I'll throw it back to you just for a quick summary of what people said.
I did, sure. So for the first question, in your organization, how long does it take to go from ideation to production? This was fairly split between 1 week and 1 month. So, fairly quickly for you to deploy something to production. In terms of how many people are on Azure today, it was, again, pretty split between those that are and those that aren't.
Okay, thank you. So I'm
Sure.
a little surprised at that 1 week to 1 month, because I think the question was ideation to production. So you got to think of it, decide you want to build it and get it out there. But it is true. I mean, with the cloud today, you can do that. When we talk about the data warehouse being a 30-year-old architecture, but still going strong, 30 years ago, it was hard to get started. You had to figure out first everything that was going to be going into that data warehouse. How much data you're going to be loading on a nightly basis, how much data would be in there after 3 years. And you had to figure all that up front, because you had to go out and purchase your servers. You had to figure out how much disk you were going to need. You had to understand how many people would be accessing that data so that you could get the right amount of CPU and memory to handle all of that. Today, working with the cloud, you can just jump right in, start with something small, get it up and running. And then as your needs grow, you can just scale as is required, right? We don't have those limitations we did before, where we invested in a server, that was really going to be it for the next 3 to 4 years type thing before we retired it and got a new one. So glad to hear that this group does get things moving quickly. And we heard it was split, so let's assume those are moving it quickly or doing it up on Azure. I think when I think about the big changes in data warehousing over the years, one is certainly what I talked about, just how fast you can get going and no longer having to provision and get all that hardware to do it ahead of time, plan that all out. But the other is 30 years ago, definitely we were talking relational database when we talked about data warehouse. And nowadays, the data warehouse really encompasses both a data lake and a data warehouse, but relational database for the component of the data warehouse. And that was to meet some of the evolving needs that we've seen, because, as we talk through some of these next slides, 30 years ago, if I go back to my first data warehouse, which would be about 25 years ago, if you could get data loaded on a nightly basis, every day you had day-old data. If you could do that 90% of the time, you were pretty much a data warehouse god type thing. And nowadays, you're going to get people who are talking about real-time data needs and needing data to be streaming into their data warehouse. And the bar has raised quite a bit. Back then, we were just worried about supporting some basic reporting. Same thing. Today, we have to do a lot more. And today, pretty much all businesses are data businesses. From what's available on social media to find out, how your company might be trending, to people, using HR services and accounting services that might be available on the web, but then can feed you data down to your own data warehouse. there's a lot of information out there, and the amount of information is just constantly growing. Things like RFIDs and tracking and things like that. You think about that parcel that's coming from Amazon. It's pretty easy to see every jump that parcel takes in its life of getting from a warehouse someplace to your front step. So gathering and managing the data, is the first step, but then figuring out how you're going to make decisions off of it, right? That's where the analytics comes in. And without analytics, data doesn't serve any role. And, 10 years ago, 15 years ago, when storage started to get very cheap, and we started to get Hadoop as a way to store unstructured or semi-structured data, companies just started collecting everything they could and keeping it and saying, there's got to be some business value hidden away down in there. But it was hard to get at that business value. And, it started off in data warehousing with pretty much parameterized type reports. Then we started moving to dashboards, and then we started moving to self-service and things like that. But even with those sort of tools and self-service, it's often more about answering questions that you already know what the question is, right? And you've got a pretty good idea what the answer is. You just want to start measuring it. When we start getting into augmented intelligence and machine learning is when you can start really exploring your data and finding information that may truly bring value to your company. And that definitely is a big change, right? So analytics business needs to evolve into data science, right? It empowers us to go further. You need scalable analytics. You need a whole lot of compute power to do this. So that was really a limiting factor. If you go back 15 or 20 years, you had to buy a server that could run your mega giant query, and it might take 24 hours for that thing to run and go through all the data and come back with a model. But then that server might be idle for the next week and a half, and you would have been paying for the cost, to own that server all the time. As you get into the cloud, you can just scale up your compute as needed to do the AI and ML. And I'm going to talk about a case study in a little bit that Insight has done, which really helps to demonstrate the value that AI can bring. But that's also moved over the last 30 years. I mean, you can go back all the way to SQL 7, I believe, had a data mining component built into it. But how you leveraged it wasn't too easy. And what you did with it was really, again, finding a pattern, but then you were kind of just reporting on it. When we talk about automated intelligence, it's really after you get those models going, not just using it to provide information to human eyes, but starting to integrate it back into your systems to make automated decisions for you. So one thing that hasn't really changed too much is the basic diagram of what a data warehouse looks like. For years and years, it started at the left and then it moved to the right. So, it always starts with sources, right? The data warehouse is a collection of information across all of your systems. And there is the notion of transactional reporting, right? If I've got some cloud data that's my finances, well, my accounting team might be able to just run reports straight off that and get the whole picture that they need. But if I think of an example of when I built a data warehouse for a large mortgage company I was working for, the accountants were only interested in the accounting information. But when I got to the C-level execs and the CEO, he wanted to see accounting information in terms of how many mortgages are being sold. But he wanted to see that information combined with HR information so he could see how much he was paying his top sellers, because someone was making 3 times as much money, he would expect 3 times as much sales. And he also wanted money brought in from our servicing application, right? It was how did those mortgages do after they were sold? If someone's selling a lot of bad mortgages that go into default, right, it starts to take a different picture. So the idea is to take all this various data from your transactional systems and start bringing it into a single repository. In the Microsoft Azure world, Data Factory often plays the role of the orchestrator. It can go out, pick up data from on-premises, from other cloud providers, from SQL or other database solutions that are up running in your own cloud and your own subscription services. And it can do some transformations and cleansing of that information, bringing it over. We've also seen over the last few years, Azure Databricks starting to make a big push into the ETL space as well. It's especially good when you've got extremely complex models and things like that that you might want to be building because you've got a lot more scalable compute power and a lot more hands-on coding options in terms of doing stuff that's fairly complex. Data Factory, which I'll give you just a glimpse of today because there's a lot to see in Synapse Studio, but we'll look at it a tiny bit. A lot of that can be done in kind of a point and click and define fashion. Databricks are really out there writing code in notebooks, which you'll also get a bit of a glimpse of, but in Apache Spark. And then there's the Azure SQL Data Warehouse, which it says now is Azure Synapse Analytics. I think of Azure Synapse Analytics as being the bigger, more comprehensive picture, which we'll see soon. And in most of Microsoft's documentation, what was Azure SQL Data Warehouse would be referred to as a Synapse SQL pool or a Synapse database pool. This was Microsoft's MPP appliance that came out around 2012, 2011, 2012 as an appliance hardware software solution you could purchase along the lines of a Teradata or Netezza. It was called PDW, then it became Azure APS, Analytical Platform System. They migrated those same concepts up into the cloud as Azure SQL Data Warehouse and have now rebranded it as Synapse. And really what Synapse is, it's going to take a lot of features that Microsoft already had and just bring them into one sort of overarching service and give you one tool to work with it. The other thing that's starting to make a big play nowadays in data warehousing is the notion of a data lake. So just a place where you can drop files, whether they be structured, unstructured, semi-structured. If you're leveraging Databricks, they have a product as well called Delta Lake, which will help you track changes and make it seem a little bit more like a database. And the point of having this sort of information is your data scientists, the people who are going to go and explore all kinds of information to try to find out, is there some pattern we don't recognize? We want to run extremely long queries and may have to bring in data they purchase from a third party, is not to have to worry about making it schema bound, getting it into that relational database, but being able to just have a huge collection of information that is queryable, even if it's only partially organized. I say partially because if you think of similar to folder structures, you are going to manage all the information that's falling into your data, going into your data lake. The term out there is don't let it become a data swamp. So you do want some organization. The idea is it's a place where you can keep all of your information and get information in a much quicker fashion and still make it accessible to people who want to do machine learning, Power BI, or machine learning, data modeling, Python scripts, R scripts, that type of thing. And then to the far right is just the reporting, the Power BI aspect of it. So you can see in that this slide, we had said before Azure Synapse Analytics was what was Azure SQL DW, but it's more encompassing than that. So Azure Synapse Analytics now refers to some on-demand SQL capabilities using Apache Spark that's now built in and easy for anybody to do. It's the SQL Data Warehouse. It's Data Factory are now Synapse pipelines and exist within the Azure Synapse Analytics world. So it's a much larger, all-encompassing place. So a new end-to-end analytics platform that brings together data ingestion, big data, data warehousing into a single unified service. So I talked about how AI and machine learning have become so important for large companies. So this was a healthcare conglomerate who owns multiple hospitals, and they brought in Insight at the beginning to work on a data warehouse with the plans of heading towards some AI and some modeling. But it started with a data warehouse in terms of let's collect the data and get it together. And it fits into the Synapse story because it was an Azure SQL DW data warehouse. That was the platform for collecting all of this information together. And then the first goal of it was to actually try to reduce patient time in hospitals. What would often happen is Someone would be in a hospital, they'd be told that they were going to be able to leave the hospital the next day, but come the next day, not all the necessary steps may have been followed. And so then it would get pushed off to another day and potentially another day. So they collected information from all of their systems, and then they started doing machine learning to try and discover what were the primary causes of delays. And that started off with just information being reviewed by humans, making sure the model made sense and things like that. But the place that it started to become automated intelligence was when they started hooking it into some of the systems that would put orders out for what was needed. And for example, something that came up was people who might not be able to care for themselves that easily on their own. There would be a requirement that they have a social worker visit them prior to leaving the hospital to make sure the home situation was going to be conducive to continuing their recovery, et cetera. And that was one of the main delays of getting that done, because these were not hospital employees who did that work. They had to be scheduled to come in. And so they used machine learning, hooked it up with the system that would request for these social workers, and started grouping appointments together so that the person would show up to do 3 or 4 cases rather than one case here, one case late in the afternoon, and another one in the morning type thing. And then they continued using this model over and over and over. And over time, things changed. Once you took care of that problem, that was no longer the main issue preventing the checkout, right? It might have been getting that doctor's final sign off. And he might have visited yesterday afternoon and not realize he had to sign a release order. And then he can't be found the next day. So they start, making sure that people knew what actions to take. That was so successful that they then switched into models to start looking at things that included seasonal statistics, just who was coming to the hospital on a regular basis, and they started predicting what their staffing needs would be. And in the long run, the number of models they put out was literally thousands of models. They started using models for hiring people and for screening people applying to their HR. And their CEO got up and has said that there has been a savings of upwards to $20 million a year per facility. Now, this has been a multi-year journey. So this isn't idea to implementation in a week or a month, but they've seen some immediate returns early on and just kept building and building and building on it. And this is something, if I go back 30 years, would have never have dreamed of seeing happening, this kind of integration. And again, having those models come out and leverage the data warehouse and feed back into those automation systems or automated systems. So I'm going to move on and talk a little bit about the data warehouse and the data lakes. So Harvard Business Review, everyone knows that data is very important, yet people are still responding that they're struggling to become mature users. And a lot of people are saying that data is still siloed, right? And it's hard to get all that information together and there's roadblocks. And sadly, this seems to be the same. I think just the bar's gotten higher. What is becoming mature users of data today is far different than what it was 20 years ago. But people always sort of see these best cases like the last one I just referenced. And it's, how do we get to that? And that is a journey that can take a while to get to. But one of the complications has been that you kind of had 2 user groups and 2 platforms to support, right? You have that data science group who want to look at big data. They wanted to be running on Hadoop. They want Apache Spark. They want to be able to use Python and R. They don't want to have to wait on IT at all. If they've got some other data, they just want to get it loaded. And then you've got your business analysts who are much more focused on the specific cases that might impact their business unit. They want the key data that's related to their business unit and the ability to go in and query it in an ad hoc fashion, build their own dashboards, reports, potentially for their business unit to use, right? So the first thing is, securing it, right? That is a tough thing to do these days. Especially with some of the requirements that are out there. If you're a medical organization and you have HIPAA data, then you have to be audit and tracking and be absolutely sure who's seen what when. And now I not only have to do that maybe in my relational data, but with all this unstructured data as well. So you need to come up with a way to be able to look at both of that, or both of those, and getting them secure. And in the past, that little white off to the right there saying relying on views, people often use views in order to handle some of that on the relational database. With Synapse, they have released row-level features into the relational database, and you can also put row and column security onto your data lake. Not quite as easily as you can do it on the relational, but it can be done. So if you're going to start letting people drop any kind of information in, you have to know what's going there so that you know what there is to secure. So Microsoft has tools like Data Catalog that can help you to scan over information and categorize it as being PII information or healthcare information, credit card information. The enterprise authentication. So, if you tell someone that they have to use a SQL login or some other login besides what they sign into their computer every day, and then you say, hey, to be extra secure, we're going to change it every month, they're going to down on a post-it note because you're changing it too frequently. It's different what they sign in on a daily basis. They maybe don't come to your data warehouse that often and they're going to forget it. So both of these areas now can be secured by using authentication with Active Directory as you're querying your cloud sources. Not everything has the same priority, right? A data scientist might have something that's got to run for 24 hours and might think, as long as I get the answer in the next few days, that's fine, right? They're playing sort of the long game in exploration and finding out what's going on with your information. Whereas someone who's running a business report and just got a call from their boss to come discuss a certain situation, they expect to get a dashboard open in a matter of seconds and be able to drill down into some specific data. So we've got different sort of demands on it, and executive queries are high profile, although rare. That's been something that ever since we got workload management of any sort into SQL was always given the case was let your CEO stuff run as fast as possible and slow everybody else down. Kind of a shell game. I think we should really try to deliver speed to everybody, but we'll call that example out since it's on the slide. So in the cloud, you can scale up. So I can just keep throwing clusters after clusters after clusters, and I can try and meet everybody's needs. The problem with that is there is cost to it, right? If I bring a cluster online, and then once it's up and running, and then the big data science guy finishes it off, and she doesn't tell me that she's done with it, and doesn't bring down the cluster herself, and it stays up and running, things like that can cause your dollars to go up. So we need a way in order to be able to scale up, use it on demand, and then let go of that compute. And then the last one is having a real data lake, a place to just drop information in file formats such as Parquet. Parquet is a columnar compression format that just gets you a lot more data for a lot less space. And you want them to be able to look at that data as well as querying what might be in your relational data warehouse at the same time. And then version control, tracking what's going on. The stuff on the right, your business analytics, some of those reports are key reports, corporate KPIs. You need to have a history of the changes that are happening. You need to make sure somebody can't push a change that's going to break a report or give wrong information. All that just to get to here, where we see that ease of use, fast exploration, privacy, security, dependable performance, all rolling together into Synapse Analytics. With that, let's take a look at the Synapse Analytics preview. So the first thing is, I know a lot of you are already in Azure. I want to say if you're not in Azure, if you haven't played with Azure, you should. And if you go to Bing and type in Microsoft Azure, first thing you're going to see up here is this create your free account today. So I would certainly give you a month's worth of playing around probably and getting, just learning a little bit and seeing what it can do. So that would be my first piece of advice. Second thing is, as you start talking about Synapse Studio, again, we just went into a public preview on May 19th. That's the first time I got a look at it. And this is how I got started, was looking at this tutorial. So this tutorial will take you step by step. If you've never done anything in Azure, create your free account, follow this tutorial, and you'll be able to do a fair bit of what you're going to see in this demonstration today. So for the sake of time, I am not going to be, setting it up, not that it takes all that long, but setting up my Synapse workspace. But you can see I do have this Synapse Analytics Tasker workspace. I won't do it, but it is as easy as start typing in Synapse and then just selecting that workspace preview. And literally 3 or 4 minutes later, you'll certainly be done your work. It may take a little longer to spin up your first one. But we're going to go into this preview, and from there I'm going to launch the Synapse Studio. So this is basically the home page. They talk about these here on the left as being the different hubs. But before I jump off the home page, the thing I'd want to highlight is this too. If you just want to get in and you wanted to start playing with Synapse, you go to this Getting Started hub, and it'll give you an option to select a SQL pool, which you would have named when you were doing your creation. So you can see I have some, and they'll load sample data into it. So you can just come in here, select your pool, hit query data, and it'll give you some sample data to get you started. So that's the home page. I can jump to pretty much anything from here if I want to. There's lots of ways to navigate. You can see again, they're trying to bring everything together. So ingesting data, looking at it, analyzing it, doing visualization with the Power BI. This isn't completely into the preview as of yet, but it should become eventually that this would be a replacement for your Power BI desktop. But I'm going to start by looking at data. The one with the little house, as I guess, is the warehouse. So I've got 2 SQL pools, so Synapse SQL pools. So these are that MPP system where it's one control node and many compute nodes, so it can scale up extremely high. And then I've also got some Spark databases that got created. So these are really just similar to Hadoop, data stored in a Hive structure, as I've done things with some of my on-demand SQL. So I've got those workspaces, and I also have linked information. And so I've got storage accounts. So this would be ADLS2, Azure Data Lake Storage 2, my file system. And if I dig into it, you can see it just sort of seems like folders, structures, things like that. So I've got some folder information. And one of the things we talked about was how it's now data lake and relational. You know, both of these are becoming important. And so right now I'm looking at data, and it happens to be CSV, but we'll look at some other types of data in a little bit, certainly at least Parquet. But I can come in here and pick on something and start looking at that file right from here just to see the sort of data that's in it. But I also have options to do things like this. If I've managed to push this information up, and that's as easy as uploading data from a flat file that I have someplace, I can immediately, if I want, push that information into, we're going to put in that Get Started SQL pool, schema and a table name. We'll talk a little bit about this today. It's a deeper sort of topic, but this is the storage that's going to be selected for it, clustered column store. And I could have just hit a box and had it done for me and throw the script, and it generates the script for me, right? Where it's going to create that table for me. I had no column headers in it, so I got 1, 2, or 3. I could have put column headers as I went. And then it's using a new command called copy, which is optimized for Parquet, which is a standard format, but it'll also bring in CSV. And it basically created all the information to point to that file, and it's going to take it and it's going to bring it into my SQL pool over here under my workspace. And so I'm connected to the Get Started, hit run. And if we come back over to the workspace, there's my temp demo table, right? And then again, I can go from there to start looking at information. Or we'll see a notebook, a little bit of a notebook in this demo, create a notebook where it automatically creates the Python or the Spark scale. In this case, it does Python Spark, I believe, for the CSVs. That first DF stands for data frame connector for a notebook to be working with. I'm going to show another example of a notebook in a second. One of the things, I don't know if you guys watched, but back last fall is when Microsoft made the big announcements about Synapse, and they were showing this cool thing where they were right-clicking on Parquet files, and you could do more with them than you could with the CSV files. And so I'm going to get some Parquet files from my CSV files. And so I have two data sets here. And if you've worked with Data Factory before, these are the data sets from Data Factory. Basically, Data Factory is moved in as Synapse pipelines, and the various pieces you're going to find throughout these hubs, be that the data sets, the pipelines, the triggers, I think, are down under Manage. But these are pretty straightforward things. These are just pointers, right? I'm just saying I've got something called my stage CSV. I'm saying where it's pointing to. That's that ADLS storage. And since it's associated with Synapse preview space, I was just able to collect it. The file path, it's in stage. It's a comma delimited piece. And then I have another one, which is Parquet, which I'm going to put into the Lego Parquet. And it's also on that same file system and a path. In order to get Parquet files, let's close these so I don't do any windows. If I go down into, before I do that, I need to upload some files. So show me how that is. Let me go back into here. I have this source of stage. So I'll upload that. And I'm coming over here into pipeline, and I have this copy CSV to pipeline. So I have a for each loop. But what I want to do is come in and look at the activities. And again, I was saying that when you're using notebooks, you're going to be writing a lot of code in notebook, but you've got a lot of control, et cetera. But when you want to talk about sort of standard tasks, and you'll see there's a fair number down here, and we've got a slide later, so I won't go too much through. But I pulled out a task for copying data. And basically I'm saying, where am I getting it from? I'm getting it from stage CSV. I am passing in an item by setting up a parameter for that for each loop. And where am I copying it to? I'm going to sync it to this Parquet one. And since I've defined that data set as being Parquet, that's all I had to do to translate these from CSV into a Parquet format. And then I'm just going to delete those afterwards. I'm just going to come here and say, trigger now. And you can see it's down here and running in progress. So again, if I can develop up here. I can work with my databases from up here. I was able to upload into my storage from this one interface. Now I can monitor what's going on at the same time. Taking longer than I would have expected. Let's see if it's starting to go here. So stage is empty because I had a copy and a delete. And the Lego Parquet have been updated to 1239. I'm East Coast. And so the reason I wanted to go to Parquet is because Parquet had some other options when I saw. I had preview before, but now I can come in here and do a select top 100 rows. And let me run that. The thing to note here is I'm actually running this now SQL on demand. So I didn't have to go and configure any compute for this. I just said connect to SQL on demand, and back in the back end, Azure is taking care of it for me, spinning up enough compute power to execute this very simple query over my data lake. And then if I come back as well, again, you can see, oops. Too many windows, right? There's also this idea of bulk load. I'd done a bulk load from that CSV file, but this one's also giving me the option to do a create external table. And bulk load means I took something directly into my database. So you can see I can go to my Spark pool here. I'm going to go to my relational again, this getting started. And I'm going to call this, I'm going to call it 10 in case I did one earlier using a script. But the difference between a bulk load takes it and puts that information directly into the database. What this one does is it creates an external table, which is basically a pointer. It's going to point to this Parquet file. It could actually point to, if I had inventory of mini figurines coming in on a daily basis, I could have another folder structure over it called mini figs and just have all the Parquet files under and point to all of them to get a view of all the information as I go through. And I'm doing something similar to that right now in a project for a large healthcare where we use the data lake as our primary EDW. But it's going to be a pointer, yet it'll be available within my SQL server. So I'm connecting to get started. I hit run. And this has to go through a couple of steps. It's got to create a external file type, a format saying that it's Parquet. It has to create an external data source and point to that and some credentials. And then it creates that external table. And these have been around for a long time. This ability to do an external table, existed before it made it to the cloud. But the thing was, you had to pay someone like me a fair bit of money to write that stuff for you every time, right? And even I was doing it for quite a few years where I was focused on APS, the predecessor to the Synapse Azure DW. I'm often going and referring to other information to get my syntax correct and things like that. So now that this is executed correctly, there's a select top 100 here. If I pull this up, I should have some results. There they are. And so that was just from DBO external 1, but one more try. Get started SQL. Well, it is in preview. Just to show. So now I'm definitely in that get started SQL. Doesn't know anything about that create stuff that happened over there, but connected directly to. And again, it becomes a reference now where I can pull that information back. So just a couple of more things in this demo. Do a time check. We looked at this was the data hub. Came down here once to monitoring. This was the pipeline. So this is basically sort of like data factory. If I come into here, again, get back into my data factory. And this is a place where you keep your sort of development scripts. So I think one of the last things I want to show is just this. I'm connected to SQL DB1. I'm gonna execute this. It's just this feature that's been added in where I can immediately visualize what's going on. So I'm going to add the number of passengers that were in the taxi to the line. So here's one passenger, right, through 6 passengers in a cab, which I hope was a minivan at the very least. And the sum of the trip distance is showing here on the legend. I'm going to look at it again with actually the count of the number of trips, because looking at that first line, it kind of jumped out that, maybe people who are on their own take much longer trips, but really you can see it follows the same curve pretty much in terms of numbers. And that's because people take about the same distance of trips. It's just you have a lot more single person cab rides than you do 6-person cab rides. But again, a quick and easy way to sort of take a look at what's going on. And there was an average distance. And if we just bring that on, it was, too small a variance to see when on the scale with the number of trips, et cetera. But the average difference of distance for cab rides didn't vary very much from a single person's ride to a 6-person ride. And the last thing just to quickly show would be a notebook. And the reason I want to do that is we saw attached to SQL on demand. We've seen attaching to relational databases, ability to move information back and forth there. At this time, I'm attached to a Spark cluster. And the first time I came in here in my dropdown, I basically had to create new, I believe, since I didn't have a cluster to begin with. And I am by no means a administrator type for spinning up of Hadoop, Apache, compute clusters or things like that. But I'll show you in Manage in a second that it's a pretty easy thing to do. So the reason they call these notebooks, so this would be similar if I was running in something like Databricks as well, is I can actually come in and append code or text. So you can sort of write out the steps that you're doing, but you're able to create data frames and take them all the way through. And you can actually change the language as you go, from Spark to Python Spark to Scala SQL. So you can, within one notebook, start doing a fair bit of work on something else. So this is starting the Spark section. So this is going to take a little while to spin up. If I come down here, this is where I can see my SQL pools. Here's my Apache Spark pool. You can see I did it small, 4 to 32, but configuring this is as simple as a new pool. I can say the size of the computer I want. So I want something with 16 virtual CPUs. And I can say I want up to 200 clusters or 200 compute nodes for that. So that's a lot of horsepower for your data scientists to come in and work with. But now they can just set it up, spin it up on their own. The good thing about this is if I'd been doing this previously and had done it through Azure, it's not necessarily going to shut down for me. This by default is going to shut down after 15 minutes of no use. So I'm only going to get charged while I'm using it. My notebook. All right, well, this is still spinning up your Spark. I guess I should have spun that up before the demo started. Just to show what it's going to do, though, it's going to create a database called NYC Taxi. It already exists over there under Spark, but if it didn't exist, it would. And then it's just other ways to now easily move information back and forth. So it's going to take data that it's going to read from this DBO trip in SQL DB1, and it's going to write it into the Spark cluster as a data frame. I can then go and reference that data frame down here in a select star. And again, we won't wait for that to spin up, but the point of trying to make with that is just how simple it now is to move information back and forth between your data lake and your data warehouses. Right click will get you started. Trust me, before the preview of this, I'd only ever done a notebook in training. I've certainly never spun up Apache Spark. That becomes pretty easy things to do. Again, my experience is much more on that relational side. So just a few quick highlights of what was in there that we saw to make sure I covered it well. Is one, there was that SQL serverless query. So there was a time I opened up a SQL query and it said I was connected to serverless. That means it's just going to spin it up for me, run the query, and spin down. I don't have to pay for compute as I go. When we talk about the SQL DW, you're paying an hourly rate for what you have, but you can scale it up and down, and you can go and start playing with it at a compute level of 100 for like $1.37 an hour type thing. Then there's the Apache Spark. Again, you can quickly create and configure notebooks. You can be exploring in your data lake, right click and get the start to a notebook, offers or supports multiple languages. And again, is a great spot for your data scientist, your advanced sort of analyst to maybe be working in. And they can take that information, share it, move it around, store it anywhere within your sort of data warehouse, Azure Synapse collective, be that data lake, be that a relational database. So we didn't talk much about pipelines, but the advantage of doing that, again, is it's going to be simpler transformations maybe than what you would be doing in an Apache Spark notebook. But there's a lot of stuff built right out of the box. Again, there's a lot of companies now who are sharing or using cloud platforms, right? So there's lots of people who have the SAP Business Warehouse. There's lots of people who might be using SAP HANA, right? Cloud, Power BI. So there's pre-connectors already set up in order for you to take Data Factory or Synapse pipelines and start connecting to services. And then there's lots of also sort of just pre-built-in components for what you want to do, like copy data, delete data, merge data, split data, filter data. Those are all things you can just drag onto the canvas and connect. This notion here on the left sort of shows you some of that, right? They've got trip data and trip bear coming in, they join it, they aggregate it, and then they're writing it to a day's stats table someplace. The other thing is this notion of wrangling data flow using the language M. So some of you may have seen this in Power BI. So it's the same principle as doing it there, where you can add computed columns, you can clean up data, you can hook it up to lookup tables to clean it up, you can add formulas, you can do a fair bit of manipulating of your information prior to bringing it into your data flow to then eventually bring it to a data warehouse or a data mart for reporting. File handling, ETL patterns, sequence generator, give me the next number, lookup transformation, I got to find a foreign key, fully changing dimensions, hash functions, add schema. Again, if you've done ETL before, well, certainly if you've done Data Factory, it becomes very familiar. But even if you haven't, the idea is that this tool can be something for that. Let's get that project from an idea to something functioning in the cloud in under a week. It can also be used by your more expert sort of developers to do very complex transformations, to load a corporate data warehouse that's maybe used by hundreds, if not thousands of users. The other piece, which isn't really into the preview yet, but is coming, is going to be the tight integration with Power BI. So Power BI right now can certainly point to a Synapse preview and get at the data sources there, but you will be able to author your BI from right within Synapse coming soon, as this slide would show you right here as a future, like that same New York taxi type information. So that's the information you'll get if you do that initial, starting out, give me some new data. So lastly, I want to talk about, the kind of thing, a new class of analytics is to, again, make sure we're clear on sort of what Synapse is and the different components of it. We saw the Synapse Studio, which is the environment that will let everybody, be it your administrator who wants to manage things, your Apache Spark administrator, someone who wants to come in and just slow things down for cost, security. We really didn't show you, but that's in the studio as well as analytics, working with the data, all built into that one developer experience. Synapse Analytics as a whole represents all of this. It's a data lake, kind of an orphan child, but definitely connected. So in some shots, they show all of it being Synapse Analytics. And then we've got the SQL component of it, the Azure SQL, what was Azure SQL Data Warehouse. And so that's what I'm going to focus on in this sort of last section, is talking about Azure SQL Data Warehouse evolved. So again, it's a product that's been around for a while, 4 years or so in the cloud, maybe 5 years now in the cloud. Was an appliance before that you could purchase from Microsoft. And, but where it says Azure Synapse is, we know already Synapse is more. We saw serverless SQL, but they did, when they announced Synapse, also announced some new capabilities into the Azure SQL Data Warehouse. So, first off, a marketing slide. So this would be taking comparison data from TPC-H model. So that's the Transaction Processing Council. H is a data warehousing model. And they have a whole bunch of test queries. And it was basically running all those tests. What did the cost end up coming out to be at a 30 terabyte sort of volume? So, stands for what it is, saying that Google costs a lot more, saying Snowflake costs a lot more, saying Synapse Analytics came in. You can find the details behind this if you want to dig in on the web to look at those sort of pricing. To me, the big thing about the pricing is, this is hey, we're running a set. Let's see, let's compare the prices. But you can get very good pricing long-term with Synapse Analytics, especially as you manage it and make sure you're scaling up and down as is appropriate. The one thing that's now there that was never there before is sort of building into this T-SQL syntax the ability to do some prediction and creation of a model and storing of that model. So you start to get a tighter connection with the machine learning, Azure machine learning that's been around for a few years as well. So built right into T-SQL, you can now start creating models, leveraging those models straight through your data warehouse. We've always been used to doing batch sort of ingestion into a data warehouse. but they've now supporting the native SQL streaming. So when you think of the Internet of Things, so at the beginning when Megan was talking about Insight and a lot of the work they're doing right now around like temperatures of people as they walk into rooms, measuring the distance between people, things like that, right? That's all the Internet of Things. There's devices, there's cameras with heat sensors, right? Pulling in that information and trying to bring it in real time. So that getting it in real time was not really something that was easy to do in the past. When people would say real-time data warehousing, I'd be like, you mean 5 minutes? You know, you did some sort of micro batches. But now we've got some native support so that you can have event hubs, with this another Azure service for collecting messages, and the Internet of Things hub, and have that start streaming in and get it into your Synapse SQL, into your data warehouse, so that you can have real live dashboard going on. So saying that, you know, I guess the point of this slide is the 3 reasons, right? Consolidation is one. Easy. You don't have to figure out what you're going to need in terms of size. You can just start bringing stuff into the data lake and into your relational data warehouse, and it'll grow with you. Migration to the cloud for efficient business operations. You no longer need to have your own data center, pay somebody higher prices because they're, you know, they may be a data center provider, but certainly not as large as Microsoft. And you don't need as many administrators to manage it anymore. And then the last piece is, you know, getting into those predictive analytics, right? So what those last 3 sort of all had in common was the, you know, the modern data warehousing, tracking, ingesting, analyzing a bunch of data sources, being able to do fraud protection, right? These use cases are all enabled by the fact that you've got a platform that can really scale and really give you some fast turnaround. So another case story from an Insight customer, a national sports franchise. It's a misleading picture because there's no baseball on it, and this was a baseball team. The reason I tossed this one in as one of our sort of many customer stories to pick from is it had the streaming that we just talked about and the AI capabilities. And so the streaming was actually, there were multiple applications used by you know, people who are part of the team organization where, you know, they're tracking all the information, obviously balls and strikes and things like that, but also using cameras and that to track field positions. Where are people standing? You know, where's the left fielder right now? And where should they potentially be? And actually feeding all of that information in live while the game is on, and then using AI models that have built up over years of data that they already had to try and predict whether there should be a motion or something. I was kind of disappointed when I read this in terms of, you know, you think that these baseball coaches, you know so much, but eventually this will come down to a lot of it just having the judgment to trust your artificial or automated intelligence saying, you know, tell that fielder to move a little to the left. This was also a lift and shift from an aging data platform. And again, some of the numbers highlighted here was just that, you know, with taking a day down to 6 minutes to get things loaded, and query times got reduced by 99.8%, as well as we added on that real-time play-by-play updates. And again, Synapse is pretty new. This fits into Synapse because it was Azure SQL Data Warehouse, again, as the back-end relational data platform. Again, it's just showing that unified sort of approach. We've brought that all together. You've got the serverless, you've got the Spark, you've got your SQL data warehouse, management, security, monitoring, all in one. So talking about the SQL piece more specifically. So you can have up to 128 concurrent slots simultaneously on one SQL data warehouse. That's a fair number of queries. We need to consider that, you know, if they're only taking seconds to run, the next one coming in can go in a few seconds if it's actually got to get queued up. The ability now to determine what resources are going to get allocated to which user accounts and things like that. One of the things up towards the beginning when it said hard to manage and hard to get to a place where, you know, you're truly supporting, you know, all these different sort of workloads, was the ability to control who got what. And so now in the data warehouse, you do have some workload aware query execution. So, you know, the notion up here is you've got a group called sales, and you can say, hey, they're always going to have available for them 60%, and if they need it, we'll let them actually push their way up to 100% of the resources and give them this much concurrency. The idea being that they'll never get pushed out by that other group, and if they need it, they can take it all. Now, you probably don't ever want to let them take it all, because that's going to certainly end up with some disappointed users, but you do have that ability. And my normal example wouldn't be sales. My normal example would be that streaming data coming in, right? If I am supporting some real-time data warehousing, and I know how much data comes in during the day or during a baseball game, I'm going to make sure I have enough compute to meet those needs, so that data is never sitting in the queue waiting to come in, if that's one of the more important business processes. This isn't available yet, but coming in the future is this notion of scale-out clusters. I don't work for Microsoft, so can't speak for Microsoft, but I have heard Microsoft say H2, so second half of this year. They did announce this last fall at the Ignite conference. The notion is this is my data warehouses down below, that I can actually create multiple compute clusters. So here's sales and marketing, maybe sharing that one with some workload management, but I could create finance, their own set of dedicated compute, and do that up to as many clusters as I want, but they could share the underlying data. So they can all access these various databases, but their compute gets reserved specifically for them, right? And so it's great. It can be great from a chargeback point of view. If you're a corporate data warehouse and you're supporting multiple business units and you have to size up to the largest available, and you've got a pretty expensive Azure bill at the end of the month, it could be pretty tough to figure out who owes what and who's really leveraging it. But if I can stand up multiple clusters, and if finance says things are just too slow, and I say, well, that's fine, are you willing to spend an extra $2 an hour? I'll bump up your cluster compute, and it's all dedicated to you. I can start doing some chargeback, and I can sometimes hold my customer expectations down, because a customer who says something should be coming back in sub-second might be perfectly happy to wait 3 or 4 seconds if it's going to save them a couple of $1,000s a year. So not available yet, but coming soon. We don't have a slide for it. The other thing coming soon, and it kind of supports this in a way, or has the same underlying technology, is right now I can scale up and down my compute on my Synapse pool, but I have to kick all active queries off. So I have to wait until there's no queries running to do it, or any queries running are going to be stopped. And at the same time we see the multi-clusters, we should also say scaling up and scaling down as an online operation. And that's because if sales was running at 500 and I decide to scale it to 1,000, imagine this one is the new sales at 1,000, they'll just start scaling it up. Once it's ready, all new queries come here, and they just wait for the other queries to drain off. So we're saying there's 3 approaches to the workload management. I can split it up in reserve, so this is very predictable cost. They're saying that I can just let everybody run first in, first out. That's great, because you're going to be using the most. I've said these people always have a minimum of 60%, and they're not using anything. I'm sort of tying this marketing to 40. And this is saying if I just let Synapse pool do its best, I'm going to get the best cluster throughput. And then coming in the future is this multi-cluster scale out, which gives me physical isolation, chargeback, the most concurrency, because I could scale them up to 128 each and support quite a few users coming in. Last sort of bit here is on comprehensive security. So you've got data protection in terms of everything's been encrypted. You have discovery and classification. Like I said, that's being able to scan your data and find personal information, HIPAA information. Row level, column level security, that's new to the data warehouse. Dynamic data masking as well is new to the data warehouse. Runs and works the same way as it does in SQL Server. Authentication can be by login or Active Directory. It's easy to set up the multi-factor. You got network security kind of coming out of the box. Again, I'm not an administrator, but nowadays I feel quite comfortable spinning up a Synapse pool for someone who needs their data protected, and knowing that pretty much having it hosted in the cloud takes care of that. And I can do button clicks on these bottom things saying I want threat detection on, auditing, vulnerability assessment. First time I threw on threat detection without really knowing too much of what it is, the very next day I had an email, and it was that somebody had accessed, the data warehouse from out of state, and it was because somebody was on training. But, just sort of watching for things that don't fit the mold. All of that kind of comes right out of the box. Last piece is, see more by scaling to petabytes. And they're talking about they've got new features like result caching, so that stuff that's being requested commonly will be sitting there in memory across your data warehouse. Great for things like a dashboard that opens up at a default place. Materialized views where you can join some complex joins with an aggregate across some tables, create the view. The Azure Synapse pool will keep that updated on its own. If you change the tables by inserting records, updating, deleting, the view will update with it, but it'll be materialized so that it is actually instantiated. And then if people don't even know the view exists, but were to do the same join and select, it would just by default go and use the view. But I want to talk a bit about that sort of scaling to petabytes, right? It's a big change from when we say 20, 25 years ago. I can literally remember, talking to a friend of mine and saying how exciting it was going to be if our OLTP database got over a terabyte and how we'd be able to put that onto our resume. And, now we're talking about working with petabytes of data. And so I want to talk a little bit at the end of this just about how that works and then give you another sort of quick demo. And that's because when I did that first demo in Synapse Pool, you saw a select count star from, and I'm just writing standard SQL. And standard SQL works against the Synapse SQL pool. But it is an MPP system, right? Massive parallel processing. And what was really going on was when I wrote that select count star and executed it, that went to the control node. And the control node then leverages this query engine to come up with a new plan on how to execute it. Because when I had something like New York taxi fare data and trip data, while it looks like a single table up here where I write my query, down under the covers, it's actually 60 tables spread across Azure storage. And as I scale up my compute, each compute node takes some of those tables. So in this case, for compute, each has 15 tables. So while I don't need to know anything about how this works, how I design and create some of the aspects of my architecture are really going to impact what the performance is for that average user up here. And I'm not going to get too deep into that, but I'm going to show a little bit in terms of a demo on that just because. So let me just run this. It's going to drop and create some objects while it's running. We'll talk a little bit about what it's doing. So there's, as I said, there's 60 tables sitting underneath these covers. So as I go and I create this by doing a select jar into DGs, my dim geography saying default. On the Azure Synapse pool, there's a table type, and the default is that the distribution is going to be round robin, meaning it's going to try and sprinkle the information across those 60 nodes evenly, and my storage is going to be column store compression. And so when you just do a select star into, you're just going to get the default. If you do a create table, you can be specific. So now I'm doing my same table, dim geography, but I'm making a replicate table, meaning there's one copy for each distribution. So it's replicate, and I'm using a storage type of heap, no column compression because it's such a small table. And I've created some different types of tables. And with these, so I've got a sales by region table, two of them, SBR1 and 2. Both are hashed and distributed by a column. But first thing I want to show is this. So I'm going to go look into this sales by region table I created with a clustered index, column clustered index. And then I'm reading the tables. That's where SBR disci exists. But then I'm mapping down into the table mappings and the node tables. And you can see down here that returned in the bottom corner here, 60 rows. So those are those 60 underlying tables that make up the logical reference of this SBR distributed CI table that I created. And I ordered it by the row count, right? And so you can see my smallest table's got 51,000 rows, 51.7, and my largest has 127,000. And so right off the bat, well, it's good to have distributed because remember those 4 compute nodes each take 15. But what you have to imagine is that under the covers, 60 queries get, when I say select, top 5 from this table by something, at the lowest level, 60 queries are going on, one against each of these tables. And this one is 2.5 times the size. Oh, no, there was 125. So this one is 5 times the size. And so while this query would be 5 times faster, it can't give the results until this extremely larger query has been happened. Now we're talking 127,000 rows to 25,000. We're talking, a second, maybe less. But when you're talking about tables that have billions of rows, how it's being distributed becomes very important. So now I'm going to just execute a couple of queries against some of those tables I created. All right, so I've got my default table joined to the sales by region, just another one to give me some little more complexity by postal code, joined to this definition geography table, and I'm grouping by a value. And this is something available in SQL Synapse pools. I'm putting a label on it so it's easier for me to find the information I want. So those both come back. And again, these are coming back quick because I'm working on a very small database. If you were at Microsoft Ignite, you'd be seeing petabytes. They'd be paying a lot an hour. I'm paying $1.37 an hour for my information. This just shows that with the default, it took 15 seconds to run. My one where I specified the tables, I took it down to 9 seconds. But remember we said at the top there was a control node, and that control node got this query, right? Select this. It then translated it and came up with a plan to say, how am I going to run this against all of my compute nodes? And there'll be no test on the details here, but the thing to show is my one with the table default had 16 steps to it. The execution plan to make that work took 16 steps. When I took a little bit of control just by saying how I wanted those tables created, it was reduced down to 8 steps, right? And so, again, the point being, how you set it up is going to matter. This one's just a default of a few fewer columns. You can see there's things here though, right? Things are running on all distributions compute, right? A shuffle move, all distributions compute. So I can make this a whole lot faster, even if it was 16 steps, by going and pitting more compute nodes, because I really only have one, but it comes up with a plan as though there's many, because the expectation is it could grow. So controlling the table types can make a difference, for sure. Now, the default was round robin. And I went against my default one and I went against my distributed one. In this case, they both took 3 steps because there was nothing complex about that query. So, it's fine. It's going to be fast. It doesn't matter what it looks like. So just wanted to sort of demonstrate that, because sometimes you'll get a bit of a smoke and mirrors with people who will do the testing at a very simplistic basis and saying, look how fast it is. There's one other thing I want to show, and this is just because it's, again, a common problem on a lot of customers that I see. And that is that we said we were using something called column store compression, right? And that means across those 60 tables, you've got 60 subsets of information, and that data has to be compressed. Well, in order to compress data by row, you need a certain number of rows. And in order to do it optimally, you need a fair number of rows. And since there was 60 buckets, the default number that SQL's looking for is 1 million rows in a bucket, and it'll automatically compress it for you. And so while I created these default tables just the way that I do my select star into and accepting that as my storage, here's the number of rows I have, but you can see they're all sitting in something called this open data store. They're actually still being stored as rows. None of them have been compressed. and none of these would be compressed until I got up to about 60 million rows. So if I started another 20 million rows, I'd start to see some compression happening. But by just taking the defaults and not worrying about it, there's a good chance you have a lot of data not sitting compressed. So you need to make choices along the way. And so if this were to try to fit into that tips point of view, my tip would be that while it seems straightforward and easy and there's a lot of compute power, by default, turning it up is not the way to go. There's a lot of great information out there, on Microsoft's site that will get into the data about polymer compression, how to make sure it's compression, how to run those alter index commands, how to go and measure it, that sort of thing. But what I just showed here is by now having those rows compressed, the same query with the same distributions, just the change being the compression, went from 15 seconds to 6.6 seconds. So these things matter. And again, I'm working on AdventureWorks, a very teeny tiny sort of database. And if you're working with billions of data, there's a difference. So one of the things you can do, and just a bit of plug-in for Insight at the end, is Insight's developed a set of scripts and utilities. And without going into too much detail, earlier I ran this, which was script the recommendations for schema DBO. And I took this output here and I pasted it here. And what it does was just looking at the AdventureWorks, and I've changed some configuration because AdventureWorks is so small, I wouldn't get many recommendations except make everything replicate. And it came back with a bunch of recommendations of things that should be changed. And you're going to see things like these push delta rows being, hey, I've got columns that have never been compressed. So that's a simple one and easy to apply. But if I come down here to something that's more table specific, so it's saying dim promotion, it only had 16 tables or 16 rows, so you should store it as a heap. The table type should be replicate. Gives you information about what it was. It was a hash with a clustered column store. And then I have the ability just to come down here, and if I wanted to execute that, just by uncommenting that, I could execute this recommendation. That at RID is the notion that I might want to review this and execute a lot. But what our utility does is the way it comes up with these recommendations is there's other procedures that you run on a regular basis, daily, weekly, that gather information. So we've captured and stored information about that dim promotion table, when it was created, what it currently looks like. It's a hash by the promotion key with a clustered column index store. There's no covering indexes. The table is not partitioned, things like that. If there had been changes over time, those changes would be here, so I could see how the table had changed. We also collect information about how this is being used. How's it joined on, what is used in where clauses to help make recommendations around indexes, et cetera. So there's a complexity that doesn't matter when you're running your very small database on Synapse Pool. You start to get into very large data. For the amount of money you might spend by upping your compute from 500 to 1500, you could do better to potentially talk to Insight, have us come in and do some tuning on your database. And again, we've written some utilities to help speed that process up. With that, back to the presentation. With that, we're at the Q&A portion. I'd ask you to take time to fill out the survey that should be posted, I think, in the channel to your right. So we appreciate your feedback. I put this up, just to show what a close Microsoft partner we are. Megan did call out, that we're a great partner to work with. I've worked with some different consulting firms. I'm really happy to be at Insight, and the level of expertise and the people that I can reach out and lean on is fantastic. So with that, I'll ask Liz if there's any questions that have come in that I can try to address.
Thank you, Ted, and really great presentation today. We did have a couple of questions. The first is, with so many ways to query, how do I know which query approach to take?
So that is a good question. We saw that you can use the Apache Spark. We saw there was serverless. You can go in and query onto your SQL Server. A lot of it comes down to probably two things. One is how much data and where's that data sitting? Obviously, the only place it's in is the data lake. unless you want to attach it all as external tables. That means you're going to go with serverless SQL if you've got a simple query. But if you want to do something more complex and multi-step, that's where a notebook can help, because you can do a chunk of code, another chunk of code, and just sort of keep building upon your process. But a lot of it comes down to where's the data, how complex is what you're querying. That would be the difference to me between Apache Spark and a notebook, or the serverless SQL. Or if the data is sitting in your data warehouse in the relational, that's probably going to be your fastest optimized source. So if you need answers quick and it's standard data, you could pull it from there.
Great, thank you. All right, so the second question is, how do I approach migrating an on-premise data warehouse appliance to Synapse?
Well, the good news is, if you're doing it anytime soon, Microsoft has a lot of funding available to help if you go with a registered partner with them. And so that would be the good news. The other thing is, it's kind of a straightforward process in a way, right? You've got to get your data up there. You've got to get you probably, when you're moving it up, want to switch to some of the tools. If you had been using SSIS and an on-premise, you're going to want to move that stuff to Data Factory. But my advice for being anyone who's like, how do you want to do that, is if you've got a strong technical team, Microsoft has got lots of great documentation out there. You can actually go to GitHub and search for Microsoft data migration, and you'll find some tools specific to bringing Netezza or Teradata or APS up to Synapse. And if you just search in the Microsoft site itself, not for code, you'll find plenty of articles that sort of talk about the step-by-step. And of course, someone like Insight would be more than happy to help anyone who wants to start on that journey.
Thanks, Ted and Liz. That concludes today's webinar. Please take a moment to complete our survey if you have not done so already. A big thank you to the presentation team today, and to the attendees, thank you for the time and opportunity to come together. With that, we'll turn you back to your day. Thank you.